Well, hello everyone. Welcome back to the first stream in a while. Let's take this thing away here. I'm getting a bit reacquainted with my setup here after the summer. Right. Today we're going to do a little bit of level design to make some of these places look a little nicer. Let me know if the audio levels are all right. I decided to try some background music this time around to sort of break up the silent parts a little bit. So hopefully that's fine with all of you. Of course, if you'd like me to not do that in the future, just feel free to let me know. But yeah, trying this now, see how it works. Let's have a quick look at Git to see in which state I left this stuff last time around. Yeah, so I have light maps off by default here because I've actually only light mapped a reasonably small part of this level. You can see this rectangle here. You can see it even better if I turn off the fog. Really no sense in light mapping any of this stuff here because it looks like this. There's nothing here essentially. But yeah, if you keep it off, then everything looks sort of similar. It's easier to just work with this stuff here. So, I have a few things that I could be working on. Haven't exactly decided yet which one of those I'm gonna start tackling. Basically, I've reached the point now where I can actually play through the demo mission in almost its entirety. The only thing that's really missing is this elevator here. So it just has this one block here, which you can conceptually move up and down. The mission is supposed to end with this. You essentially entering this elevator here, and then it slowly starts to rise. And that's kind of the end of the mission. That's not really a spoiler. Essentially, when you arrive from over here, the first thing that you hear said is basically that the elevator there in the distance is where you will want to go. But yeah, this thing is really not done at all yet. So that's one thing that I could start working on in this video, just figuring out this elevator, how it should work. So one idea that I had is I would essentially do like a similar sort of thing to this monorail car, which is made up of essentially two parts. You have this car itself with some edges here that you can't actually drive out of, and then you have this this sort of ramp here, which can open and close, and I think that would work quite well for the elevator as well. But of course the elevator would just move upwards instead of following this track like the monorail does. So that could be something to look at. Would require me to do a little bit of programming though. Let's have a look at the monorail car component. This is the thing that actually sort of drives that monorail. What do we have here? It's actually reasonably complex. But of course this is kind of because this thing is is something that you can just like ride back and forth between these two monorail stations from here and then all the way over to the refinery over here. The elevator doesn't really need, it's sort of like the end of the level, so the only thing that needs to know how to handle is like close the ramp and then slowly start to rise. So it's a little simpler. We don't, for example, necessarily need to have like a finite state machine like this set up for the elevator. But how do we actually move this guy? One object created, probably have, yeah, pre-tick is most likely where we actually want. So we're basically teleporting it. Actually, no, sorry, I messed up by this name here, but we're setting the transform, we're not teleporting it. Not teleporting is actually somewhat important here, because if you're teleporting and you have like another object that stands on top of the thing, if you're teleporting, it's not necessarily safe for that other object to stand on top of it. So that's why we need to specifically not teleport it, but rather keyframe it around so that any dynamic objects on top of the monorail actually sort of move along with it, right? And then we have the ramp. The ramp is just, we're just setting the orientation of the scene node that the ramp is attached to, so that's not super tricky either. So yeah, I don't know. We could do something like this, but we could also just do a little bit of level design, laid back level design thing in the straight up in the level editor as well. Yeah. Not sure which one I want to do. Maybe we'll start with a little bit of level design. So we have a bunch of things here that aren't really decorated at all. Sort of like this side of the road is almost completely undecorated, and this side is decorated and even has grass if you go look at it close enough. So we could start doing that for this side, make this look more interesting. And then when you go out here, we have even more things. Also have this beginning here. Maybe I should start with this beginning. So if you look at this from the top, you can see that the beginning terrain actually has not that, but take the fog away for a bit. We have like two pieces of terrain here. We have the main one, which is this main big one here, and then we have another one, which is this smaller piece here in the beginning. The reason they look different is because I just haven't sort of painted this initial one at all. I do wonder if we should spend a little bit of time on this rock here, on this cliff, because it's clearly sort of less detailed than this next one here to the side of it. So what do we have? We have like two pieces here of actual mesh. So we can, of course, get Blender to open itself. Have you guys noticed that opening Blender nowadays can be kind of slow? I wonder why that is. Right, so if we edit this in Blender, we should be able to see. Right, so even those rocks there are part of that same mesh. Yeah, it would be nice to have these cliffs be slightly more final. But maybe we can actually leave them as they are for now. And just concentrate on making this terrain look nicer. Even though these rock sides are kind of not the sort of wanted fidelity. You can see here that this is, even though this is pretty low poly actually, this rock here, it is significantly higher tessellated than this guy here, which is like just an older rock mesh. Yeah, let's just leave these as they are for now. And we can go and figure out this terrain here. So the terrains can have either like 8 materials or 4 materials. You can see that we have like the base one here, which is the default grass. I think this other one is set to have only 4 materials, yeah. So we probably need to shuffle around some of these things a little bit. We have just like the sort of base one, which is this checkerboard thing, and then we have the gravel, just this thing you see here, and they're probably set to have different physics materials too. Yeah, that's gravel ground, and that's default ground. Right. So we want to basically figure out which of the materials are sort of needed to have this road working the same on both. And so my guess is that we need the base one. So we need the 0. That's what was it called? I'm just gonna type this up here on paper. Good old paper. Default grass. Then we have, what is that? Material 2 is gravel. And the order of these are actually important. Like the base one is always sitting on the back. So that's material 0. Then we have 1, 2, 3, 4, etc. And they're always sort of appearing on top of another. So if you want like a material with a lower index to appear, you need to actually erase the one that is sitting on top of it. Then we have number 3. 3 is not, apparently it's sand alt, right? And yeah, I think it's sand alt, and then 4 is sand. That's kind of confusing actually. But number 4 is sand, and sand is for sure used. It's these like lighter, brighter areas here. I think those are the ones that we actually need to have this. Yeah, we have something more. Is that like the darkener? Yeah. So I have something that I call the darkener, which you can just see all these like dark areas here. It's basically just a black color that you can just ever so slightly paint somewhere, and it maybe gives a slightly more interesting look to some of these places. So we can see here, if we toggle it on and off, also allows you to like darken some like grassy patches and that kind of stuff. Yeah, the grass actually doesn't immediately update with that, because I think we need to like manually flush this texture here, which is affected by this terrain painting. But that's fine. Right, so we have number 7 is the darkener, and that means that we have 4 materials, and we can fit 4 materials into this other terrain. I'm just gonna undo everything I did. Oh, I actually moved something here. Let's actually just open the level again to make sure that I didn't do anything stupid. And we can actually start putting these materials into the this small intro terrain here, or this the terrain that's sort of sitting here in this intro section, which is what this is. So, how would we go about doing that then? I don't think I can very easily copy one material to another, like straight from the editor. But what I can do is I can actually open this level file and just copy them by hand, right? Because the level is just JSON data. So let's see. Map refinery, yes. It's called refinery blockout, even though that's not really a good name for it anymore. It hasn't been like a blockout in ages, but that was what I called it initially, and then it's just been sort of left there. So terrain 1. Yeah, here we have the materials. Quite long, actually. That's a little annoying. Yeah, I've been meaning to actually make it so that you can copy an object. But I just haven't had the time to do that. Let's do terrain 1 again. I'm gonna start copying this guy. It would be easier if we had some sort of JSON folding thingy here going. Is there any fold JavaScript functions? It's not that Notepad++ maybe support JSON folding. It does actually. Nice. So do terrain 1, and then we can fold this whole thing, and we have terrain 2 as well. Right? If we copy those guys, I still prefer to use Sublime if I can do that. That didn't quite do what I was hoping it would. Yeah, so this is terrain 1, okay. Okay, I want terrain 2 as well. Okay, come on. Let's copy that. And put it there. This is now probably... Yeah, this is just terrain 2, okay. Yeah, you can see that, like that, when we haven't modified the materials all that much, then this data is really quite short, because it just leaves out everything that's not like default values. So we have the exposed property values, that's like these things here. Then you have terrain, and then you have materials, and here we have the indices. Right. So material 0. That's everything that we want for that. So 0 goes to 0. If I map these, 0 goes to 0, that's the base material. Then we have number 2 goes to 1. That was the gravel. Then we have 4, that goes to 2. And we have 7, which goes to 3. You can map from the more complicated material to the less complicated material. Yeah, we do that. So we take all the material 0 values from here, and they should all be just in one big sort of consecutive piece here. Take that. That's 0. And I can actually just take everything else away for now. So then we have materials 2. We have those guys. So they start here, right? Yep, that's the first material 2 value. And we'll put it there. But 2 goes actually to 1. So if we do replace this with 1. I know this is kind of not that exciting to look at. This should be the only thing that we need to copy manually, sort of. Materials 4, that becomes materials 2. Place all, and then finally we have the 7th one. That's a darkener. Right. The darkener is over there, and we make that number 3. So there we go. That should be everything. I will take this and we can do, what's it called? JSON reindent. Make sure we haven't messed up the data format somehow. So that's base terrain 2. Now if we take this guy and we basically paste it in here, in like there. So the last value here is the editor position of the transform, minus 250, minus 720. That should still be the last one. Yes. The formatting is messed up, but that doesn't matter. The editor doesn't care about that. If we open this again, Funnery blockout is the correct one. We should have a green terrain there, if I've done my things correctly. And look at that. We do have the green terrain where it should be. Now you can see this edge here is not all that well done. We might actually want to sort of cover this up a little bit with something, but we can look at that separately. I'm going to save this and probably just like actually send this off to my source control. You can see here, yeah, we have the camera has moved, and then we have these guys. That's everything. That's cool. So terrain to materials, because I just don't want to do that again if I somehow mess this up. Right. Okay, cool. So I'm gonna start doing cooler things. Namely, we can start modifying this terrain here in the hopes of making this transition between the two terrains a bit more smooth and not that noticeable. in the past I've managed to hide these seams quite well. But in the past my art style has perhaps been a little more detailed. Traction point is actually, I'm using an art style that's kind of cartoony in a sense. Like this, it doesn't really try to look like actual realistic terrain, right? I don't think anyone thinks it looks like realistic terrain. And because of that, some of these edges and seams between terrains can be kind of hard to see because this pattern is so repeatable or so repeated everywhere. So if you have one of these seams, it can just look sort of sticks out a little bit, right? But that's fine. We'll do what we can to hide it anyway. So the trick is to not have like very straight edges and also try to just raise the terrain enough that... Oh, what happened? Oh, yeah, I think I know what the problem is. That it's not actually physics. So if you have this CPU tessellation on, then the terrain gets very slow, but that doesn't seem to be on, so I wonder what's going on here. Save this just in case. Yeah, you can see that thing there. Maybe it's just the case that my terrain modifier, terrain editor is not like the fastest one. It, for example, it doesn't modify this stuff on the GPU. It modifies it on the CPU, which may cause some slowness. It's again something that I've been meaning to change, but like so many things to do, and if I have a working CPU-based terrain editor, then I'll just use that for as long as I can before actually putting in more effort and time to make it GPU driven. All right. Smooth this out a little bit. It's the actual like edge of the train. It's right over there, right? Okay. That might actually have been an okay thing to have it reach kind of far into this side. Smooth it out, smooth it out. So we will cover some of this stuff up with grass. Grass is probably going to be the best way to cover this up. You can cover up quite a lot of things with grass, actually. If we just turn off the grass here. Where's the grass? You can see this edge here just goes almost completely away. But when you have the grass there, so we just need to paint some grass over here. That should basically take care of this thing for us. Yeah, just leave that there for now. All right. So then we have this road. The road is sort of a dirt road, even though it's technically like really large. If we put a scale mannequin there, we can see just how big this thing actually is, how wide it is. It's actually really big. The reason it's so big is that we want the mother vehicle, this huge vehicle, this one here, to be able to drive on it. But still, it is kind of a dirt road. It's not like paved or anything like that, and that means that the top is supposed to like be ever so slightly higher than this on these sides, because that's typically what tends to happen with dirt roads. That's also why I sort of painted this center of the road slightly lighter. That's the sort of art style I'm going for right now. Another thing that we need to keep in mind here is that the road is kind of supposed to end here. You can see the terrain actually ends here, and we have this big plane here, which sits on another render layer, which means that the height is just completely messed up. Or not the height, but the depth. Sorry, the rendering depth. Which causes it to just like things show through it in a very special way here. And that's not really anything we have to worry about right now. We could try to make this thing have roughly the same color as this one, and make this transition here a little less obvious. So we shall see if we have it here. Plane 3. Right, we have a number of these guys. Plane 1, plane 2, and plane 3. Yep. Okay. Plane 1 is just this really big one, actually. Which reaches all the way over there. And the reason it reaches all the way over there is, like, if you're standing here... Let's put the fog back on. And you see these kind of low poly mountains there in the background. You should see the plane almost like to the end of the horizon. That's kind of the idea here. You're supposed to see that as just like a very big plane. Or up here. While of course in reality they're just some boxes that I've put over here to make it look like there are things in the far distance. Right. How do we do this now? There's a primitive geometry object. Okay. We could just create like a custom material and everything for it, but if we don't have to, then let's not. What we can do instead is we can look at this terrain here. Hello. I can't select it like that. So this guy uses a texture. It's called terrain pattern this or that. Where is it? It's over there. I should be able to zoom this, shouldn't I? Yes. Terrain pattern. So it's kind of hard to see. Terrain pattern 512 darker. We can actually just copy the resource path. But it is the thing that gives this terrain this sort of this texture here, these sort of splotches of blobs all over the place. We can, at least in theory, just use the same thing here. Let's use this plane number, was it 3? And plane number 3 is this one that's closest to this. So, instead of the checkerboard texture, we'll put in this thing, and we need to just up the scale quite a lot. or actually bring it down. I don't remember which way this actually goes. Oh, there you can see it. So now they're clearly smaller than on this side. Let's try to match it. Was it actually going the other way around? Yeah. So something like that. That looks pretty good. They're maybe ever so slightly too large, and that's better. Okay, cool. And this is not a place that you're sort of ever supposed to actually drive on. Oh, we have some sea fighting there now, but that's fine. We'll fix that. It's not a place that you're ever actually supposed to drive on. You're supposed to get maybe this far or something like that, and then you get like a notification that please return to your something or other. What is this though? Oh, the terrain might be actually... Oh, this plane might be showing through. Yeah, it's showing through there. Okay, we just need to up the terrain here. Just very slightly. Which we can do right away. Just raise it up. Like so. Adilet says... hey, I'm the only one. Yeah, yeah, maybe you are right now. Yeah, we had some people earlier, but yeah, I just started maybe like half an hour ago, so people haven't shown up yet. It is a custom editor, yeah. There's a custom editor called Basis, or there's a custom engine called Basis, and there's the Basis editor. So yes, it is completely self-made. Right. Let's see. Let's try to get the color to match as well. The color would be this one that we have here, and there's a mix of diffuse and ambient, but we can just kind of... I think we'll start with the ambient one. Yeah, the terrain materials are kind of special. They're a little annoying. They don't quite follow the same lighting model as the normal sort of standard materials. This is also not a standard material because it's a primitive geometry object, but this actually creates a standard material on the fly, sort of. You can use the advanced editor for this and just up the... Need to up the value, maybe try something like 48. The editor is not written in Zig, no. The game is written in Zig. So this kind of stuff here. The gameplay and the AI and you know, the mission logic and all of that is written in Zig. The editor is written in C#. And most of the engine is actually C++. Up that a little more. Alright, so now we're kind of matching. Oh, that Z fighting is really annoying there. That doesn't look good, but we'll fix it when we actually copy those values over to the other planes, so that's not a problem. Right, and so the idea here is that when you have the fog here, it's kind of supposed to look like... we have some of the mountains there in the background. And this spline is a little annoying here. There's some mountains there in the background, and like you're not really supposed to ever go this far. So yeah, I think this will work quite well. And I might want to actually take this plane and just create a big mesh out of it. Because then I can get rid of these 3 planes here. And I can have some like some small slight variations in the height here, but yeah, for now it's just one big plane. And yeah, you can see the shadow being sort of confused here with this this render layer being different. Yeah, it looks pretty good from that direction. If the diffuse light hits it differently, it becomes sort of lighter, as you can see. We could all tweak all this to actually match perfectly if we just created a custom material for this. But I don't want it. I don't know if I want to actually do that right now. Yeah, if we untick this distant object, then everything will work properly here. But then we don't necessarily see these. Like these objects are like kilometers away, basically. You can see this position is like minus 3,000 on the z-axis, so that's like 3 kilometers away from the origin. So that's why I need these things to be rendered with as distant objects. Are you planning to start a Telegram or chat or Discord server for followers? Yeah, Discord server is planned. So earlier I mentioned that the demo mission for this game is finally completable. As of basically yesterday. So I'm working on a demo. This is the demo level for the game. The level which will be in the demo, which is probably about halfway through the campaign or something like that. And when this level is complete, I will ship the demo to you guys. Probably a little while before that, I will open the Discord server. So I just don't really have any use for it yet, but yes, it is planned. It is planned, indeed. Okay, let's copy these values to get rid of that annoying Z fighting over there. Like so. Now it looks like one big plane, especially with this fog here. That's kind of nice. Here we have this one. This is also annoyingly the wrong color. We could maybe fix that as well. You can see that it's using just a blockout green material here. That's stupid. That's very stupid. So what do we want to do about that instead? Let's go have a look. We can look at probably like node material. So we have some blockout materials like blue, brick, dark gray, green, gray, blah blah blah. So that was the green one that we used. It's just like a standard thingy. We could make a new material for this. I think we'll actually put it in the refinery. We have some handy, yeah, materials. Plateau top grass. Oh, would that actually work? Let's look at that. Right, so it opens up on another screen. Yeah. So it looks basically like exactly like what we want. If I just open that again, we can get the editor on the correct screen. It's a material variant, plateau top grass, using the correct texture. The diffuse color, ambient color look to me to be roughly the correct ones, but we can of course change those if we want to. It's based on the base material diffuse. This is probably not going to be exactly the correct one, because this is not a light mapped. You can see here GI none. Right, let me just copy these guys. Can I do that somehow? Copy them to like just a text editor, so that I can create. That's a diffuse. We want that patch of terrain there, which is currently the wrong kind of green. We want it to be potentially light mapped. This one, when we light map this area. And so we can't use that directly, but we can use it a very similar material. If we go to to probably the engine, or is it just no? It's game material. So here we have some base materials that we can base things on. So we have diffuse light mapped. This guy is probably correct one, and here we have GI light map. It would just basically pick up the light map if it is used. So we can create a material variant. We basically need to put in those same things. Terrain, pattern, and we actually did use the darker one. That was like a variant of the pattern texture. So let's use that. I'm just copying back these things here. It's not like the nicest thing here to do it this way, but that's probably fine. And then we'll do put it in the map refinery, materials, and we'll just call this like terrain mesh, something like that. And we'll build it. Material exported successfully. Now if we go here and we override the material and do terrain mesh, we can see that okay, it's kind of correct, but this multiplier here is not very nice. That's annoying. I really like the game you're doing, also because of Zig. Well, thank you. And yeah, Zig is awesome. Zig is really great. Okay. So that almost worked. That almost worked, but not quite. Because if we open this again and drag those overrides to the side, I don't know, is there any way to actually like scale the UVs for that? I don't think there necessarily are. Diffuse texture is just piped directly through to this UV node here. Okay. Okay. That's not great. Let's just save this guy as terrain mesh. So now it's no longer a material override. Now we can actually just modify these guys. And what I will do is just input these things here directly rather than overriding them. Yeah, that's not what we want. We want the darker, whatever it's called, terrain pattern darker. Right, that's probably fine. I'll add a new parameter here, which is just like texture scale. Initialize it to 1,1, and then we'll take the so I'll make that a bit larger parameter, and the vector parameter we want the texture scale, vector operation, right? Is that correct? I think that's correct. So we'll just plug that in there. We take the UV, we plug that in there, and we'll just multiply. That should be a component-wise multiplication, I think. And there's the place where we can see both of those textures. We have it over there. Just make this smaller so that we can see the change as we are actually making it. Let's try 2. Yeah, that's better, but still not enough. 4? Yeah, 4 looks pretty okay. I wonder if this darker thing here is actually... Should we actually just use the lighter one? That one, without the darker postfix there. I don't know. I think maybe not. I'll just keep it as it is. Again, we can just mask or sort of hide these things quite well with the grass, right? I'm gonna lower this very slightly so that it doesn't poke through there. But yeah, now we have the grass color is sort of like correct now in all the places. And this looks kind of nice with the fog and everything. Turn the fog off, then kind of lose the sense of scale. It doesn't look correct anymore. But yeah, this is okay, and this kind of actually flows kind of naturally into this plane here, this little terrain that we have going. But if you're standing here and the camera is probably roughly about here, this still looks like a pretty sort of straight line here. I wonder if we should just like lower this a little bit so that we can just take this in some more. And here we have some things that don't look nice, at least not up front. Oh, I actually recorded the wrong height there. Did I not? I think I did. Probably that one. Yeah, now we can sort of pull this thing in a little bit. And then we want to smooth this out so that we don't get those very abrupt changes in the height. And yeah, I have a feeling that I will kind of need to make this plane its own mesh rather than having just a straight plane. That will make it more interesting. But also might just be that this is good enough. The camera will be at like around this distance anyway, so we'll see. Right, did we actually forget to set the scale on this? Let's see, where's the plane number 3? Is that? These other ones still have it wrong. Yeah, that's why it looks wrong. Particularly this border here looks wrong. And now it looks better. Yep. Good. Good. And yeah, we'll need to do something about this mesh here. These are just completely untextured. I don't think they're even UV mapped yet. Let's open that in Blender and see. So, what's the UV look like? Yeah, it doesn't look like it has any UVs. Well, it actually does. But they're completely borked. Display stretch, yeah, they're just completely all over the place. Oh yeah, that's fine. I haven't done that yet. But that's all just one big mesh, this thing here. So I need to UV unwrap it and then I can paint some pretty pictures on top of it. Right. Okay. This already looks nicer than it did. My machine is really slow today. I don't wonder what's going on here. I'm just gonna probably... don't I have the audio stuff here? Audio, main volume. There's the main vol. Main vol. No. What is it called? Master vol. Master vol. Just put that to 0 so that we don't have this horrible engine sounds here. Right. And yeah, I think this will work once we make it a little more detailed. And you can see sort of the road sort of fading out here. This is not necessarily a very nice way to fade out a road, but that's kind of the idea, that the road is sort of like leading off into different directions. Maybe we'll even have it sort of, if we look at it from above, it's sort of getting a little wider. Might want to have it like go even wider still. You can think of like vehicles arriving from the big plain over there from different directions and then sort of converging on this path, right? And then it turns into a proper road that leads into the valley there. That might be pretty cool. Sakmoka says, yo, how's it going? It's going pretty well. It's going pretty well. Lazy Saturday afternoon doing some level design. What are the specs? I don't know what specs are you talking about. I'll be happy to tell you any specs, but I don't know exactly what you mean. But yeah, looks pretty alright. Let's drive up here and see. Oh, the specs on the PC. Oh man, if I can remember those. Let's have a look. Good question. Actually, let's just do that and then go to here. So Ryzen 5 3300, 6-core processor, 16 gigs of RAM. The GPU is some sort of Radeon. I think the game actually outputs it. Let's see. The game actually outputs it here in the beginning. Does it not? Apparently it doesn't. But it's some sort of Radeon 6650 or something like that. Let's have a look. Man, why don't I have any of my AMD something or other? I mean, it doesn't really matter, I guess, but now that we got started doing this, let's see if we can... I actually had a shortcut down there. So this thing is a... Oh, there we go. RX 6650XT. Yeah. So it's a Radeon. It's not super high end. It is also not supposedly super bad, but it's kind of mid-range, I guess. Which is how you should develop your games, people. Like if you're building a game, if it's not like a super lightweight, some sort of 2D thing which will just run on any kind of toaster, you should develop your games on. I mean, this is just my opinion, of course. But my opinion is that you should develop your games on something kind of almost crappy, because if you build it on like the latest and greatest 4090 Core i9, whatever is the high end these days, then you don't realize when it actually runs poorly. Let's get rid of that. Driving off the edge here, and let's get rid of the smokestack blocking the way. We can have a nicer look out on the plain. Oh yeah, Task Manager actually does give a pretty good look these days. Yeah, that's true. That's true. Here in the performance, you can see it. Yeah, here this would have told it. 6650 XT. Yeah, we are VSync bound now, so we're just using like 50% of the CPU. And probably like maybe a thread and a half. No, actually using like 3 threads or something. And how much memory do we actually use? Memory stats. So there's a little bit of overhead here because we're running off the asset server currently. So we're just streaming things from the asset server. This is the asset server, by the way. This thing here just converts things. So there's the terrain mesh that we just modified. You can see that it has updated it and sent it to the game. That's why like the resources are showing like 940 megabytes now. That's like way more than we actually use. Oh yeah, 2.12 gigabytes. The Zig code uses 6.3. Almost nothing. That's all the heap allocations from the Zig side is just 6.3 megabytes. And the yellow ones there are the ones that have been used recently. So within like the last, I think, second or two. Which means that you can just like easily see what is actually being used. So if I just stand still, we can see that we're using STL. The STL allocator has like 45,000 allocations. It has like the biggest number of individual allocations. And when we turn the camera, the graphics API starts allocating a lot, but it actually hasn't allocated more than 7 megabytes, so it's like a pretty big number of small ones as well. Then we have the physics and the network, and they're each doing periodic stuff. And then when we drive around, you can see all kinds of things going on. And the generic allocator, which is allocated like 800 megabytes. It's just like if you don't ask for a specific allocator, it just gives you a generic one. Just probably way too many. There's some particle stuff going on. That's the stuff that comes off the car, of course. And the renderer as well. Oh, hey, Tutu. I had a window overlapping the chat there for a minute. It's a custom engine, yeah. It is a custom engine written in C++. And the game is written in Zig. And you can see that out of 2.12 gigabytes, 6.31 megabytes is allocated by SIG, so well, almost all the resources, of course, are actually allocated by the engine, so that is why. Right. Anyway, I think this looks pretty nice now. These sort of transitions into the background. We have some borders here, or edges, where the terrain meets a mesh, and we have some edges here where the two terrains meet. Some of those I can clean up, but they will basically be completely hidden by the grass when we start painting grass in those areas. So I don't necessarily mind all that much. It's pretty nice in that sense. Right. So that means that yeah, we have some holes here because I figured no one's gonna look over here anyway. That means that we could just do a pass on the road here. Try to get the road to look kind of like the rest of the road, and the rest of the place. The road is pretty much painted, except for this path that goes around the refinery, and in the refinery itself, just like this one single colored thing still. So from there to the other side, still not done. I did a pass on it inside the lift station recently, so this looks kind of okay, I guess. And yeah, let's do this now, and then maybe we can even paint some well, add some more details to this area, make this look like it's part of the same scene. That'd be nice. Close all of that down. I think this terrain mesh material is probably good enough for now. Yeah, it's starting to look pretty nice. It's starting to look pretty sort of coherent, slowly but surely. There's something that just bugs me. Smooth that out a little bit. So, how did I do this? How did I do this road business? I think these lighter tones are just the whatever it was called. Actually, I need to name those materials before I forget. So let's do. This is like default grass, yes. Oh, the names are actually yeah. Because I copy pasted those. The names were copy pasted as well. That's fine. So yeah, it's sand is the thing that we want to paint. Right, this thing. But I think before that, I just want to make that road a bit like the base color there, a little wider. So let's do that. Let's do like something like this. And then the sand stuff will be painted on top of that. we need to consider like at which point should it start diverging into different directions. I think that is the point where well, there's no blocker here yet. You can just drive out onto the thing, and then when the terrain stops, you actually literally fall through the ground currently. That is obviously not how it's supposed to be, but currently it is. At some point we need to put in sort of like a soft or hard, but I'm thinking a soft barrier. So maybe like a physics force that, like, if you go past the point, and sort of pushes you back so the vehicles can, for example, drive there. If you do that, then if you come driving at like 200 miles per hour this way, then your vehicle will essentially sort of stop. You don't necessarily even need to tell the player anything. Like some games go like, you are leaving the mission area or whatever, and then there's like a timeout after which you die or get teleported back or anything like that. Those things always kind of bug me because they feel so heavy-handed. So if you could just like make it so that the vehicle quite simply can't drive there, I think that'll be nicer. But we'll see. And I think the barrier should be roughly where this road starts diverging into different directions. And we can't actually paint like this on just any material. We can paint here because this is the terrain. So we can't actually paint on this plane, at least not right now. I have some object painting features for certain objects, but they're not really suitable for the huge thing like this. Which means that we will sort of have to stop the player before they reach a place where they can just see that, oh, okay, all the painting suddenly stopped. Yeah, robot arm. Yeah, that would work. It is not necessarily any less heavy-handed than telling the player to go the other way. I don't know. We'll see. We'll see what happens. See what happens. And yeah, this road stuff looks really horrible, really bad until you start putting in these other materials, and then it kind of looks like Myth the Fallen Lords all of a sudden. So let's put in some grass there. Oh no, sorry, not grass, but sand. I'm on the wrong terrain actually. Sand. Ah, there we go. I'm doing the wrong thing here. Yeah. That's a bit too much. That's a bit too smooth. It takes a while to find these sort of nice settings for these drawing tools. Ideally, I would have sort of presets that I could save. That would make some of this painting a lot faster if I could save sort of the brush settings, and then and give them names and everything, and then I could just go back to those later. That would be nice. That would be really nice, actually. Not even that hard to do. I probably need to do that at some point. What's the elevation look like here? So what I've tried to do here is actually sort of dig this road into the ground a little bit, because that's what typically happens with these kinds of things. I haven't really done it on this smaller terrain. It just kind of sits on top of it, which doesn't look particularly good or realistic. Dirt roads like this are sort of like they're sort of sunken into the, also sort of, I guess, compressed or like forced into the ground a little bit by all the vehicles that's driven on them. Just not really something that you think of until you sort of see it missing, and then it's like, that doesn't look particularly realistic. And there's a way that we can actually do that sort of thing. It's a little strange. You put on a special flag here. 1 update per vertex. You need to take the fall off completely off, otherwise it won't work. And then you can make the strength whatever you want. And we can sort of paint these kinds of, like, it won't paint more than once. Essentially, it won't affect a pixel more than once, but that means that you can just lower an area like this at like a certain height. And you can always do it again if it doesn't turn out like you want. You can of course also raise terrain the same way, so like this. Yeah, I don't think we necessarily want to go lower, because the actual the plane is coming to meet us pretty quickly. And actually it just ended right where I stopped painting that, so that's probably fine. And then untoggle that flag there and start smoothing out this thing. I think we can even, that's a bit heavy. We can even ever so slightly raise that. Should we put on, turn off that one? Maybe not. Yeah, that's a bit heavy. Let's see how this works. Quite often when you do things like this, you have to sort of be kind of heavy-handed with your shapes. It won't look good, but then you start smoothing things out, and then suddenly it looks much more natural. This edge here I want to smooth with a very, very small radius, actually, to sort of leave that slope there. And then on the top side with a larger radius. And those poor trucks there haven't really been used in the game at all. I'm sure we'll have use of them at some point, but kind of don't need them in this demo mission. kind of already looks a little more like a road when it's sort of pressed into the ground a little bit, right? At least that's my impression of it. Yep, something like that. Still doesn't look like a dirt road because we haven't pushed down these sort of tire tracks or these sides, nor have we actually painted this this center part of the thing brighter or made it higher, but that will come. Right, so we don't want to make it look like we have this huge sort of piles of dirt here next to the road, so I'm just gonna smooth this out some more. And then we can start to look at the profile of the road, like the actual height of the surface there. And then we should actually probably let the intro sequence play to make sure that these vehicles are actually handling the terrain correctly, and they probably should. Well, maybe they should actually arrive from exactly where they are. I'm just gonna paint some gravel here as well. Let's see, gravel. Paint. Let's do this here. More, a little tighter with the fall off there. I'm gonna hide that guy for a second. We can see better. So now we can probably see the road sort of just ending there quite abruptly. I don't like that. I don't like that at all. So what do we do about that then? I guess what we'll do for the time being, I might come up with a better solution later, but I guess for the time being we're actually just gonna sort of feather it out here. Quite a lot. So that we don't let it sort of reach that end, because it will be super obvious to everyone that that is where the edge of the terrain is. We don't want that. We want it to be sort of like a nebulous field of gravel. Nebulous field of gravel is what I want. And in between these sort of paths, so whatever we want to call these, we can just put grass, and we can put maybe even some trees and things here. I don't want to go too close to this cliff here yet, because I want to do a final modeling pass on that cliff. It's still way too low poly, even compared to this other side here, which is considerably more final. This looks... I like the overall shape of basically these two guys. These guys, but the fidelity is not correct. So we need to do something about that. Right, maybe we should, at this point, just see the intro animation once. Right, we have the new level there. You can just run the game. Just turn off the audio again. Yeah. Looks better. Looks better than it did. Definitely. Yeah, looks better than it did, definitely, but it doesn't look particularly good. One thing that I want to test here, just quickly. And the master volume doesn't stop that. Does it? Oh, there's a little bit of a delay, yeah. It's probably due to the way I have the audio mixed currently. Right? There's a little bit of delay. Oh well. Yeah, that's nice. That's nice. I'd like this card to have a slightly different direction at the end of that intro sequence. So, where are we actually telling it to go? Let's see. Intro animation, intro camera animation. Let's unhide that guy. Scout intro target is there. Yeah. Okay, let's move it somewhere like there, maybe. Where's the mother intro target? Where's the mother go? Mother goes there. That's fine, but maybe we'll move it as well. Just so that you have like a nicer, slightly nicer sort of starting orientation when the game actually begins. Yeah, it doesn't quite affect the thing in the way I wanted, because it's probably just like following this. Actually, where's the, over there, right? Yeah, they're probably just following the. I'm just gonna move those back because it doesn't really quite matter currently. It's just following the nav mesh's road spline, so this yellow thing here, until it gets like reasonably close, and then it just stops following anything really. So it is what it is. I'll fix it at some point when I know exactly how the terrain is going to look like. That'll be better. Right. So what's next? I think we'll probably want to do to continue with this road here. This for a little while. Yeah, I seem to be a little light on audience and streaming audience today, so I'll probably not gonna keep doing. I'm not gonna keep this stream going for like hours and hours. But we'll do a little more, and probably do this at least for like another half hour or something like that. But it seems to be a little slow day today, which is fine. Which is fine. These things are gonna be available as VODs anyway for anyone who's interested. Oh, let's try to make this look natural. This is like there's a pretty obvious sort of border here between these two currently. Need some more gravel selected. That's why we can't see anything. Now we can see. Now we can see the lightness here of the sand. Right. So what do we want to do? We want to probably do something like this. I'm gonna put the strength down even more. And just paint sort of roughly in the middle. Like sort of, luckily for me, these are just dirt roads. Which means that you can just paint them sort of freehand. It doesn't matter. In fact, you kind of want them to look a little wobbly and organic and strange. It's not like a paved road or anything like that. Which, to be honest, you would probably use some sort of spline tool to do. But yeah, dirt roads you can just do this kind of nicely. So we have this this obvious difference here in the lighting, and that's because we're sort of we are we have these two sort of surfaces here meeting, which is not super good. We should probably go to the first terrain, the bigger terrain that is, and just probably kind of like record that height and apply it here. And you can see that you can sort of have it go away a little bit. Let's put the strength down and just up this ever so slightly. And then do a little bit of smoothing. Not too much. Here we have something similar, but I think this light patch here is too bright. So no, that's the wrong tool. That was the wrong material. Something like that, and then maybe do a little more gravel there in the background. And then kind of erase that. And again, we need a little more gravel there behind it all. Make them sort of match. Well, that's pretty damn good, if I may say so myself. Almost can't see that seam there at all anymore. I mean, like over here. That's really nice. Yep, that'll work. That'll work. I mean, yes, you can see it, but almost invisible. A little more gravel here. Oh, sorry, sand. But it's not actually showing up. Why is it not showing up now? Oh, it's because I'm on terrain 1. Yeah, this is the problem with these tools. You can see it sort of disappearing into the terrain there. And that's because now we are actually painting terrain 1, so it's this big one on this side. This is terrain 2. So this follows terrain 1's features, and then when it intersects with the other one, it kind of goes into the terrain there, and you're like, huh? What's going on? And that is the reason. Right, but I do want to paint here. Come on, paint. You know what? You know what that probably is, actually? That is probably the darkener. Take the darkener away. Yeah, that is what it was. I just painted some darkness there. Right. Johan Lind asks, how is it to be working in Zig in your own engine? If I understand correctly, you use Zig almost as a game scripting language. You understand almost correctly. I do have a scripting language in the game. You can see here the script editor. Let's find something that has a script. This guy. This is Angel script. So it's not technically Zig that I use as a scripting language. But you are kind of correct in the sense that, like, if you consider it from in say the context of Unity, where the scripts are sort of like the gameplay code, and they can be sort of, you can write systems and features and all of that in C# there. In that sense, it is sort of like a scripting language, yes. So this is the game code. The game is written in Zig. The engine is C++. And so there's a lot of sort of interfacing with C++, which is kind of, it's not really tricky, but it's not as easy as interfacing with C. If you had a game engine written in C, then using it from Zig would probably be very easy, because Zig has very nice C interop capabilities. Not so much with C++, and it's not really Zig's fault, it's just that C++ is just impossible to talk to. So you have to do it through a C interface. Because of that, I've had to do a little bit of plumbing to actually have it interface with my C++ types. So the trick here is actually sort of like this. If we look at this, look at one of the blueprints here. And this is not to be confused with like an Unreal blueprint, but rather like a game object type. So we have the scout vehicle, which is one of the main vehicles here in the game. This is how you add components to a game object type. And we have a bunch of components here. This is a little small. I'm sorry, I can't make this larger because this is just Win32, so it doesn't support any sort of scaling or anything like that. But you can see here that you have like this basis : then something, decoration object component, for example. And then you have things that are like something dot, and those are the Zig components. You have a means.ai driving component, for example. And an object can have both C++ components, such as this dynamic body transform component here, which is pretty big. And then the next component is a VHL.vehicle controller component. So you have, within one game object type, you have both C++ components and Zig components. And that makes certain things really cool, because you can just use all of the reasonably well battle-tested C++ components that you have and combine them with Zig components. But that also means that on the engine level it complicates things a little bit, because C++ doesn't know anything about Zig. And a game object is essentially like a collection. It has a, like, literally, it has a vector of pointers to components. So the Zig components need to be represented somehow in the C++ code base. And so I've had to write some adapter types there. So that they can be represented. Let's see, but you had some follow-up questions. So engine C++, game is Zig plus AngelScript. Yeah, game is more than Zig plus AngelScript. I also, I like to make things complicated. I do quite a bit of node-based things. I'll get back to the SIG and C++ stuff in a second. I'll just answering your question here about what stuff I use to build the game. So this is the mission is actually created with this kind of script. So this is a node-based system that I use for all kinds of things, like material shader code generation and things like that. But I also use it to just run scripts, because scripting a mission, this is just the demo mission, but it does get kind of complicated if you can't get sort of like you can't like jump around in the flow depending on which path the player took, things like that. At least I like to sort of script out my mission flow using a system like this, where you can sort of wait for conditions, you can read things that are called global variables. It's just like a list of things here. You have variables that are sort of connected to the mission. They can be booleans, floats, ints, etc. And then this flow graph here can track conditions. It can wait for some of those booleans to be true or false or whatever. And then in the level editor, when someone has like a trigger, so we have a bunch of triggers here, junction trigger area, for example. You can see that we have like some triggers here. When the player gets this far, essentially, we just set some of those variables to true here. So it's sort of like a mix of this kind of node-based scripting and AngelScript. AngelScript is used mostly just for like I call it like glue code, because it glues together features that are written in C++ or SIG, and then the flow, which sort of keeps track of the overall like progress of a mission, for example. So it's a little convoluted perhaps, and I would like to get rid of AngelScript eventually. I don't really have there's nothing really wrong with AngelScript per se, but I do feel like I could just replace AngelScript in here with like this node-based scripting, which is completely custom made. So I know that code base pretty well, and then I'd have one less systems to worry about. And is it a big hassle to expose the C++ to both AngelScript and SIG? Yes, it is. Short answer is yes. It's not like continuously a big hassle though. I did a little bit of upfront work to make that happen. So I have something that I call bind a lot, which is a tool I use to bind things. So this is the bind a lot file. Let's see if I can make this larger. So this looks like this is how I bind C++ types to AngelScript. And this looks kind of like C++, but it's not C++. I do have Visual Studio Code treating this as a C++ file, so that I get the like syntax highlighting and things like that. But it just complains about everything because this is not valid C++. But if we have something like take like what should we do? Like a camera. Camera is probably a pretty simple class. If I can find it. Oh, there it was. Right, so here's camera. This is like a literal class in C++. Class in this bind a lot file basically just means like, hey, we have a group of functions that we want to treat as methods of this thing that we call camera, right? And these are all the methods. If you get a pointer to a camera in Zig, these are all the methods that you can call on camera. and they will be sort of forwarded back to the C++ side. And that's kind of important that we do that. I mean, I could just create a new camera class, or shall we say camera struct in Zig, which would be like a native camera thing. But if you want to just use a type that the engine gives you and sort of manages internally, then of course you need to somehow communicate with the C++ side, and that's why for quite many things I actually expose the C++ types instead. And so this, you can see that we have just like a uint pointer. This is sort of like the int, or the this pointer to the C++ side. And then if we go have a look at camera.zig, you see all the same methods here. And we just have a cpp ptr, which is like usize. And that's why actually I call this type camera ptr. And this is sort of a convention that I have, that anything that is actually wrapping a C++ pointer in Zig ends with this ptr type, because this is its only member. It is really just representing a C++ pointer. So it gets that C++ pointer, which is a usize from somewhere. It doesn't really know what it is, but it knows that we can store it in this camera pointer thing, and then when you call set perspective, we just pass it back. And this set perspective, this is stuff that is then generated by the bind-a-lot system. Let's go back to bind-a-lot. Here we go. This is again the bind-a-lot file. You just run this, and it generates a bunch of things for you. You tell it the types here, and it kind of knows what types are, at least the types that I tend to use, what their counterpart is in Zig and in C++. And it generates like a whole bunch of function pointers for the camera. So you can see here, this is generated. These are the function pointers that we can use to hook into C++ side, and then it generates like these kinds of type aliases for it. This is all generated code. So if you want to add like a new thing, if you want to bind a new function, a new method on the camera class, the only thing you need to do here is add one new line here with the correct parameters, and you run the bind-a-lot tool, which is just a small exe. Well, I have it here actually, and you typically run it with this batch file, which like takes the class bindings that we just looked at as the input, and then it generates like a header file, and generates those types and bind functions and function pointers in Zig. And then C++ has this generated headers, or whatever it was called, generated class bindings. Probably can't be found there actually, but we can find it if we just follow these things. Bind camera function. So this is a giant header. You can see it's like 4,000 lines almost. That is also generated by bind-a-lot, and it just does essentially sort of like the opposite side on the C side. So we have a camera function, and again you have like camera underscore set perspective, this thing here, and the bind camera function, you just need to call it with something that does, you know, the thing you want essentially on the C side. So here we call bind camera, and we give it a bunch of function pointers. We look at this function here. What it does is it reinterpret casts. Make that a little bigger again. Reinterpret casts the CPP pointer to a camera, and then you can call set perspective on it. So there are some hoops to jump through. The cool thing about this is that like adding a single new method to be bound to a type is actually really easy, because you just add it to the bind-a-lot file, and then once that is done, actually the C++ code won't compile anymore until you've created like a function here on the C++ side to handle it. And because this is C++, I actually need to wrap all of this in extern C, right? So these are just C functions. Actually, I probably wouldn't need to do that because it's a function pointer. I might actually be able to get away without this here. But anyway, and then you pass that to the bind camera thing. And bind camera is one of these functions that is generated on the SIG side. So we have bind functions. Bind camera is right here. This is the function that we're calling. It's a C export, sort of exported function from the SIG DLL that we built. We could just give it all those function pointers and then set them here. I assume the C++ components never access stuff from SIG components, but the other way around. Kind of, yeah. Kind of, yeah. The C++ components typically don't kind of mess with each other on the engine side. Like if we look at like hauling, not hauling manager, but hauling, was it hauler component? This is from another game. This is not traction point, but like an earlier incarnation. So this is actual gameplay code. And what you can do here in gameplay code is you can get the game object and then you can get a pointer to like a component, for example, like this. This is typically not really done in engine code, right? So you wouldn't see this behavior all that much in traction point on the C++ side, because the C++ code in traction point is mostly like engine code. But you could do that. You could do that. You could get a pointer to a SIG component, but what the type that you would actually then want to use would be SIG game object component, this guy. And this is sort of like the adapter component. Every SIG component gets this kind of component as sort of an adapter. So if you call, you know, on message received, for example, on this, what this does is that it actually does call message received then on the SIG side, using the SIG-C API again. So C++ components can call things on the SIG components, yes, because it, for example, they need to be able to send messages to the SIG component. But it goes through this kind of adapter component thing. And C components, in the same way, they can call things on the C++ components. They can't, of course, get any like pointers to a C++ component because it doesn't really know what that is. It doesn't know what that would look like, right? So if you have, go to one of the game components here, driving component is probably a pretty good example. Let's make this a little bigger again. So game on object created. This is essentially the same thing that we now do here that we just looked at in C++. You get a game object, and again, this game object is a game object PTR. It works exactly the same way as the camera. It has a C++ pointer, and basis int pointer is really just an alias for usize, so it's exactly the same. And you can get a component out of this. You could not obviously ask for like a C++ component here. No, you can't do that because it doesn't know what that is. But you can get any SIG component out this way. And then the things that the C++ components uh, 'Offer you, such as like transform things, 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 'Offer you, su or meshes or things like that. Those things are then accessible using other means typically. You don't necessarily need to ask for a transform component if you need to get the transform. You can just do self dot. Like if I wanted, for example, to get the position here, you can do const pos equals self dot context dot transform dot, and then you can get like, you know, position which returns a vector 3, or you can do world matrix which gives you the matrix 4 by 3 or whatever. Some of these things, they do come from the C++ component, the transform component, but I've created these kinds of simpler APIs to actually access that data rather than having to do a bunch of like horrible casting everywhere. Cool, that's how I do it in my engine as well, with a C++ component called Lua script component that then can hold a all kinds of Lua components like player, etc. Yeah. Yep. It it does work. That's all I can say. I'm not sure I would do it necessarily this way if I was to you know, start now. There's quite a bit of legacy sort of baggage or quite a few legacy reasons for doing it this way. I will say that adding like a SIG layer on top of the engine like this does complicate things, and that's not obviously a good thing. But basically how it went is that I had this C++ engine which I liked working with, except I don't like C++ itself, at least not for like day-to-day work, and I wanted to try SIG, and so I just for like shits and giggles I tried to see how much would it take to actually expose this to SIG, and then it sort of just went from there, kind of organically evolved into what it is. And what it is quite nice these days, but I still say I probably have like maybe like 30% of the engine API exposed to SIG or something like that. There's quite a significant part of it that isn't exposed to SIG, and I probably won't expose more than half. How did I architect my components? Yes, so it is basically a pointer-based solution, like you say. I don't think I will move to ECS with this engine. I actually have a video where I sort of put an ECS into the basis engine. You can look at that if you want to. It's kind of rambly and weird, but you can just use ECS with a very specific part of your engine if you feel like that is something that you want to use. What I have is something called a factory, which kind of sounds horrible and like Java-like, but it's actually not. Game object component factory is something that gets generated for you. Like if you have a component here on the C++ side, you put this sort of macro here and give some information about the component. But basically what this does is that it generates a factory for you, and I think this is actually, let's see if I can find it. It's templated on the type that we actually want. And we have a batch size here. So how many of these components do we actually create in a batch? And then when you create, let's say you have a transform component, for example, that needs to be updated. That's actually probably not a good idea. Let's say an animation component that needs to be updated. Maybe you have like, 100 of them or something. So if your batch size is like 32, for example, that would mean that rather than creating those components all in one go, or sort of creating them as individual things on the heap and then using a pointer. I create them in batches, like this. I think the batch size is 64 currently by default. And so if you have 100, that would create 2 batches, and then you have them right next to each other in memory. And when you update those animation components, you can just update them right next to each other. The user still sees the pointers to things as pointers, but the updating doesn't need to go through like a million pointers to update things, for example. So that's kind of nice. I don't use virtual calls to update. No, I don't. So this has a generate has member. So this is basically like, let's see if we can find this actually. So the factory has a virtual update, right? The idea here is that if you have, let's say, what should I pull out of my hat? Let's say you have 10 component types, and for each component type you have 100 instances. If you had a virtual update function for the components themselves, you would have to do 10 times 100 virtual update calls, so 1,000 virtual update calls. Instead, what I do is I have a virtual update function on the factory. So that would be just 10 virtual function calls. And then the factory figures out with this Sphinai helper here if we have an update on that. So if we have a look at this, there's a little bit of template magic going on here, which is not really something I like all that much. I can show you the SIG version of this in a bit, which is much nicer. But basically, this creates a small helper class for us, which figures out, hey, do we have this thing member name here? And then essentially stores that value in here in this bool value. So if we look at the update for, we have update internal here. Try to go there, please. So it has 2 of them, and it has one where there's like an standard enable if. So if we have this is the thing that this Sphinai helper generates for us. If we have an update member, then we call update on the components that need them. And if we don't have that update method, then we just have an empty function. So a much nicer version of this is the SIG version, which basically it does work a little differently, but I don't think I'm actually doing any batching on the SIG components currently. Something that I need to do at some point. But let's see if we can find this. Right, so SIG of course allows you to do things like this, like has update. And then we can look at that. And you can see here update is just like it's a normal method on the factory, and it just checks has update, and then it gets the list of components and then runs the update on them. So yeah, you can see here that this is I think this is a component list. Where's component list? Yeah. So this is an array list of pointers currently, but technically we could do like the batching here as well if we wanted to. The user interface to this wouldn't change at all if we did that. And so basically my point is that I use virtual functions where I kind of want to, and I don't use them in the places where I don't want to. So the game object component here, this is the sort of base for my C++ game object components. They have like virtual create and destroy functions and object created function, things like that, but they don't have a virtual update or a virtual tick, because those tend to get updated the most, and so I just don't do that. And then in Zig I have something that I call the context, which is kind of like the poor man's base class, because it's tricky to port a system like this to Zig if you don't have any kind of base class functionality. So if you have the brain component here, for example, anything can be a component, but it needs to have a context field, and the context needs to be one of the supported contexts. And so this is sort of like almost as if deriving from game object component, right? And then the context just gives you a bunch of things. So that's kind of how it works. If you want to actually, if you want to see how to bind AngelScript to Zig, then I have a video on that as well. I think it's one of the transmission series videos. Let's have a look. Where is it? View my channel. I think, yeah, so it's this guy here shows you actually how to bind AngelScript in Zig. But like in a nutshell, I don't expose any new types to AngelScript from Zig, like all my strings and vectors and game object references and things like that. They're exposed on the C++ side, and what I can do is let's see, I think it's called trigger area. Yes, trigger area is a component that can be scripted. And this is interesting because this has like events that can be called. So I just create two new events here on object entered, on object exited. So if you go here, now we actually already have them, but you can see that you get like auto completion here for these two types for this trigger area, and that auto completion and everything that comes just from these guys, and we register them here as these are like events that this thing can receive on the script side, and then it also has three special methods that can be called. And kind of like the nasty thing here is that you again need to pass like self pointers using usize instead of just using a self pointer, and they have to be called conv-c. So I typically, what I do is I have like an increase hit count with an underscore, which does a little bit of pointer casting, and then calls the thing with the actual name, right? Like this. And then of course this thing can return errors, so it has this bang symbol here before the return type, and AngelScript doesn't know anything about Zig errors, so I need to like catch errors here and just error out before going back to the AngelScript side when calling this. So yeah, it works. It works. But it's not the nicest. And so because of things like this, I'd like to just eventually get rid of AngelScript and just have my own node-based thingy here, which I can sort of make fit the Zig workflow a little better. But that's it. That's it basically. Gotta go in 5 minutes. Yeah, I'll probably end the stream reasonably soon as well. Final question: how do you handle maintaining game code being up to date using latest engine features? With a lot of pain is the short question. I have a couple of projects that I keep sort of working with the engine, and I try to. If I know that I'm gonna break something, I'll try to just update it by hand in the other project as well. So yeah, I don't have any sort of magic thing for that. I do suggest, if you have multiple game projects, I do suggest just having a TeamCity server running on like a machine in the corner. That is what I do. So, oh, not that. So there's this thing called TeamCity, which you can just download for free and use, I think, with like 3 agents. And I just basically have like a single little Windows machine sitting in the corner, running the TeamCity software itself, as well as being the agent itself. And it basically builds my data and the game's code, and then you can have it run automated builds, which I currently don't do actually, because I don't have any sensible builds in Traction Point. But that would be a possibility. And with that, you can catch some issues quite nicely. And yeah, I highly suggest, if you have something like the asset server here, which is sort of converting your data for you, I recommend adding like a command line interface to this guy, which you can then use to control it, so that you can plug this into your TeamCity or whatever you use as well, and just have it like reconvert all the things for you. So I can, for example, download just a zip file with the latest code and data from the build server. Yeah, GitHub Actions probably works. I haven't used that, but I know that is sort of a thing. I don't think I could use GitHub Actions to build this data, because building the data for my game actually requires a GPU. Maybe you can do it with like a virtualized GPU or something like that, but I don't think I could. Well, I don't know if GitHub Actions does support running things on like a Windows machine, but if it did, and you could do it with a discrete GPU, then that might be just a-okay. But the virtualized GPU or Linux system, I don't think I could build my game on currently. The runtime works on Mac, and at least like in theory on Linux, but the converters don't. So not sure how that would work for me, at least, but it might work for you. So if that is the case, then sure. That's great. I think they have NVIDIA powered runners actually. Yeah, that maybe they do, but what operating system? My textures, for example, they're essentially like DDS files. They're not like straight up DDS files, but they're DDS files that are contained in like a special custom container, and they're converted with like a Microsoft tool that uses compute shaders to do that. I don't know. If you can get that running on through GitHub, then sure. Gotta go. Thanks for the stream and discussions. No problem. Have a good one. Hope to see you again in the future. Let's do a little bit of work still on this road, and then wrap up for today. I'm kind of tired, and it seems to me that everyone is kind of tired today. So, whoa, that's not what I want to do. So we did this side kind of nicely. I can't even really see the seam there anymore. But this side is not good, so let's fix this. Let's fix this up. We have the sand selected. I do wonder I do wonder sort of how much this discrepancy here is like painting and how much is actually normals just being slightly different. It can be kind of tricky sometimes to see, like, do I need to make this brighter, or do I just need to like change the angle of the surface a little bit? Yeah, that's way too strong. I think I'm getting pretty close. I mean, technically, I wouldn't really have to put this much effort into this particular thing right now. There's still a chance that this will change, but it's been bugging me for a while that this is so visible. This edge here, that it's just nice to fix it up a little bit. One annoying thing with this, with these terrain editing tools, is that the strength is sort of not necessarily the same across the shaping tools, or the tools that actually allow you to like shape the terrain, and the painting tools can be wildly different feelings with those. Oh, YouTube is complaining that I am not pushing enough data. Let's hope that's not like a big thing. So painting tools typically require a higher strength to actually be able to see anything. And the shaping tools typically require less strength. All right. Yeah, I think this looks reasonable. Looks reasonable. There's a little bit of something like this. I don't know. More sort of small details here than there are elsewhere, but we'll add more of them elsewhere, so that shouldn't be a problem for very long. Kind of like starting now, essentially. And then every now and then you need to just look at, like, compare that to the rest of the scene to see, like, if the sort of look and feel is the same. It doesn't need to be necessarily the exact same. I mean, it's a different place after all, but you want kind of the art style to be the same. Still. Paint some like large detail sandy areas here. I want to be kind of careful near this border that we don't add like a whole lot of big details unless we want to paint it sort of on both sides. Because of course that is what you have to do if you have some features that sort of cross the border. Second, I'll get some more water here. Yeah, this is sort of relaxing work to do. Time kind of flies. I do wonder if I should just become like a professional level designer, because I just kind of like doing this stuff. I don't know if I would like to do it as much if I didn't get to decide exactly how I want the levels to be. But yeah, I've been meaning to end this stream a few times already, but here I am, almost, what is it, 2.5 hours later. Yeah, we will end soon. We will end soon. But let's try to get this road into some kind of shape. A little bit of gravel, and then we'll press down on the tire tracks, or the sides where the tires would be if we have some vehicles driving along this. That can be kind of tricky actually, so let's make sure we get that done nicely and correctly. And And then we'll probably use the darkener to add some slight highlights here. Right, so how do we want to do this now? So basically, like these darker places, they should be depressed a little bit. Yeah, not that much, but maybe that much. Something like this. Do like undo and redo. You can see that it gets pushed down a little bit. Like this. And this just tends to give it sort of like a dirt road feeling. And then you have to occasionally smooth something out. To the side a little bit. It's not necessarily super important that the AI spline goes in the very middle of the screen, but it can be a good idea. And then of course you need to play this road, to drive on it. That's very important for a car game. Sometimes you make something that looks super nice, and then you drive on it, and your car just gets stuck, or it just bounces around or whatever, with the sort of intended speed that you've meant for that place. It's not really something that's a thing if you're making a character-driven game, but car games have this annoying tendency to feel different from what they look like. Let's put some depressions on these places as well. Just need to be super accurate, and we actually don't want to most likely depress them all that much. You can see some small changes here. We'll do a little bit more. Yeah, something like that. Let's do a bit more sand here. I wanna make some more sort of sharp features, and some more sharp features to this. And then I think we'll do a little bit of darkening using the darkening material. Yeah, I think that probably will be quite all right. What do we have here? Is that maybe gravel? It's not really gravel. There's something a little like darker about this, but I think it might just be the lighting. So let's just smoothen this out a little bit. That's probably fine. It's probably fine, you know. And of course we can paint here outside of the road as well. Like a small sand pit here or something. We'll need to put some trees and things on some of these places. Rocks, what have you. Yeah, this pipeline here is also very bare bones still. It's just made out of like individual pieces like this that don't really even fit together, so it's really just like a white box version so far. But yeah, looks all right. I think if we take away the darkener material here, I think it looks kind of like this now. Maybe we'll want to have just a few more sort of like broader sand pieces or sandy areas next to the road like we have over there. Where should we put one? I think maybe here, maybe over here. We have one area that's like just like slightly wider sand. Roads don't tend to have very uniformly wide sort of side features. And here probably. I think when we actually get to adding trees and things like this, it will look really nice. Then we have to consider that this is the path the camera will actually fly when showing the intro cinematic. It kind of goes like this, like ooh, then follows the car. That's the thing that you see in the intro cinematic there, where the cars are driving past the camera. Alright, something like that. What about the darkener then? What did I actually do? I just kind of painted some features. Just painted some features with the darkener. Basically just kind of followed the overall shape of things. Right, so you can just paint things, make them a little darker. Okay, let's do that. Just a little bit. Where's the actual edge now? It's good because I can't like immediately see the edge anymore. That means that I did a reasonable job with actually hiding the edge. Which is nice. It's just nice. kind of like that. It's just basically a way to get a few more extra kind of shades of these colors here. Without like having a bunch of extra materials. So there's really no kind of rules for how to do this, just a little something kind of makes the area pop perhaps a little more. I can toggle it on and off and see what the difference it made. Very little, but probably enough. Yeah, I don't think this plays all that well yet, but we'll see. Yeah, I can just play it from the game and we'll get the intro cinematic there as well. Why not? All right. Yeah, it's nice because you don't really see the edge at all anymore there, so that's good. Mission accomplished in a sense. And yeah, this kind of feels like a road. And then at this point you will be like be suddenly stopped. Yeah, that'll be fine. I'll add a component of some sort there that you can add. It's like an area which just kind of smoothly stops your car and pushes it back. That should be quite enough. We can add an on-screen thing which is just like the level ends here, whatever. Yeah, I think it'll be fine. It will be fine. What about this other area that we did a little work on with the material changes and everything? Basically, what I would want to achieve is sort of the feeling that this is just all one big area out over like a big field. And you can actually have your mother vehicle lift you up onto this part here. You can just spawn different scout here and just move to that. And yeah, you can still see the edge here, as I said, but that will get covered by the grass. That's not going to be a problem, except might actually be a problem. The problem will come from the fact that the grass takes its color from the terrain, right? And the terrain ends somewhere around here. Yeah, so that could be a little bit of an issue, but it's probably not a big issue. I will just paint this in a sort of a gravelly way so that there's not much grass here on this side. Yeah, that'll work fine. It'll be fine. And then here, closer to this side where we actually have terrain, we can have grass. Yeah, that'll work. That'll work for sure. And then here, you can also see that big plane there, and it kind of just looks like a big plane. It's fine. We have some meshes here that we still need to color correctly. But that'll be handled when we actually texture those meshes. They'll just look like this one here, which is which has sort of grass-colored top. Cool. Cool. Right, I think I'm probably gonna end this stream here. We got this area kind of nicely set up now for actually like decoration and some other areas here tweaked up a little bit as well. The thing that's nice is that I now see that yes, this will probably work visually as a big sort of plain, big grassy plain. So I don't have to worry about that anymore. But yeah, quite a lot of work to do still on this level. Anyway, if you enjoyed this stream, if you're still with me, then I thank you for your time. Be sure to subscribe to the channel if you haven't done that. And stick around because I am working on the demo and sooner or later it will be available to play. So that's something to look forward to if you like what you're seeing. Other than that, have a good weekend. Hope to see you in the next video or stream. Take care and bye.